Hi everybody, in this video we are going to be working through unit 11.1.3 quotients or products and quotients raised to powers. So have your notes handy as we start to go through this. So similar to the last lesson and video, we are going to be expanding some things first to discover the rules, and so that's what we're going to do here in this first one. So what we have, if we're expanding it and then we're simplifying it, we have 5 sets of 2 times 8. So 1, 2, 3, 4, and 5. And I'm going to bump all the 2's to the left and all the A's to the right. And I'm just kind of doing that step in my brain, but that's what I'm thinking about, moving all the 2's to the left, all the A's to the right. And then if we're taking 2 times 2 times 2 times 2 times 2, we're taking 2 to the 5th, and you should be getting 32 for that. So again, I urge you to put that in your calculator, or if you know that one in your head, go for it. It's going to be 32. And then if we were doing A times A times A times A times A, I would say, well, what rule does that look like from the previous lesson? And that's the one where we're going to be adding up our exponents, right? Because it's the product rule of exponents. So how many of those do we have? We have 5 of them. So we're going to have 32 A to the 5th. And then just kind of looking at what we ended up with versus what we started with, I'm hoping you can at least look at the 5 on the A and say, well, how does that compare to what we started with? And it looks like it's the same exact number, right? So if I had written out with the base of 2, how many 2's did we have? We had 2 to the 5th times A to the 5th. And 2 to the 5th is going to end up giving us 32. So looking at our next problem, if we've got 4 sets of this 3a over 5 times 3a over 5 times 3a over 5 times 3a over 5. And again, I would urge you to count them up. How many 3's do we have? We've got 3 to the 4th. We have a to the 4th. We've got 5 to the 4th. And so again, putting those in your calculator, you can take those in your calculator, plug them in and say, well, what is 3 to the 4th? Or you can say, well, what's 3 squared? 3 squared is 9 times another 9, because it'd be 3 squared times 3 squared. So 9 times 9 is going to give us 81. 81, and then we've got a to the 4th, and then taking your 5 to the 4th, and you're putting that in your calculator. I think you should be doing 625. For that one. And then again, you'd look to see if you can reduce it. If you borrowed one of my calculators, there's a little button on there. You can hit the 81 and then the fraction button. The fraction button on the calculator, some of you came by and checked it out the other day. The fraction button looks like that. And if you did 81 and then you click that fraction button and then you did 625, it would check it for you to see if you can reduce it at all, or you can just use your divisibility rules as well and check that and see if you can reduce it, which you can't. So we've got our rule here that says a product raised to a power rule. So if we have some product, and remember product is multiplication, right? So it's the answer to a multiplication problem. So that might be something you jot down in your notes. A product is an answer to a multiplication problem. Our rule is going to be a to the x times b to the x. When it says caution, like math sirens should be going off in your head right now. Do not try to apply this rule to sums or differences. This is addition and this is subtraction. So if we have something like this, it's a quantity raised to the x, it is not going to equal, a to the x plus b to the x. It will not equal that. Remember, we talked about that 2 or 3 lessons ago, that it won't equal that. And then on this one, it will not equal a to the x minus b to the x. The only time, I'm hoping you remember, the only time that you can distribute that exponent into the parentheses is if you have a product or a quotient. That's the only time, not addition, not subtraction. Let that siren go off in your head a few more times to make sure you don't ever do that when you have addition or subtraction, because it will not work. Then it'll give you the wrong answer. All right, so what's the rule if we have a quotient? So if we've got a quotient, it's going to be a to the x all over b to the x. And then this is recall, we've already done this rule, but remember, for any non-zero numbers a and b and any integers x and y, if I want to rewrite them so that those exponents are positive, remember they flip places. So we're going to have e to the y all over a to the x. And so that's going to be your final answer on that one. Then for this next one, again, recall, we've already done this rule, but if you have a negative outside the parentheses here, in order to make it positive, we switch those places. You end up getting b over a to the x. If you don't remember the y behind that, I did the y behind it in a few videos ago. And essentially you're just distributing that negative x in to both of them. And then it kind of looks like this situation, right? Except it'd be a to the negative x over b to the negative x. And then you flip their position in order to have a positive exponent. But again, that was in a previous video. All right, so we're gonna do some examples. Here we go. We have got negative 2m to the 5th all over z, and we are raising that to the 3rd power. So again, check, look inside the parentheses. Is there anything we can reduce? No. Is there anything, any addition or subtraction in there? No. I mean, I know there's a negative on the 2, but that's not subtraction. That's just a negative on the 2. So if there's only multiplication, which is what we have here, and only division, which is what we have here, then you can go ahead and distribute that exponent of 3 into the parentheses. So we're going to do that. And so it's going to be negative 2 to the 3rd times m to the 5th times 3 all over z to the 1st times 3. And we're just going to keep simplifying that. So negative 2 times negative 2 times negative 2 is going to give us negative 8. And we're going to have n to the 15th all over z to the 3rd. And so then that gives you your answer for that one. And I'm going to just point out that there's lots of ways to do these problems. So you may have approached the problem a little bit differently. And as long as you're coming up to this solution and your process is still accurate, I don't care if it's different, but the process does need to make sense mathematically. All right, so the next one, we've got x to the negative 4th times y squared all over x to the 2nd times y to the negative 5th. So again, I urge you to kind of pause the video and try it, because my method on this one might not be what your method is. So you should try it and see what you get. On this one, what I'm going to choose to do, it's a different way than what you've seen, but maybe some of the rest of you have tried this method on previous problems. What I'm going to do on this one is bring everything from the denominator up on this one. So that means I'm going to take this and I'm going to subtract 2 off. And I'm going to take this and I'm going to subtract off a negative 5. And we're going to see what I get. So then I'm going to get x to the negative 6 times y to the 7. And then if I said, no, I'd like you to express your answer in only positive exponents. Okay, well, I can do that. This is the only one that's causing a problem at the moment. And we're going to have y to the 7th all over x to the 6th. And that's going to be your final answer. Another way to do it, which is what I have been telling you, is that you would look at the x, and because the original x in the numerator, and because it's negative, I would have had you drop it to the denominator. And so you would have x to the x squared times x to the 4th in the denominator. And then this one, some of you might have said, well, that's negative. So I want to bring it to the numerator to make it positive. So then in the numerator, you would have y squared times y to the 5th. And then you'd combine them, right? Y squared times y to the 5th, adding those exponents, 2 and 5, is going to give you 7. And in the denominator, you would have added x squared, or multiplied x squared times x to the 4th, and then added their exponents of 2 and 4 to give you 6 in the denominator. So that's another way to do it. And that's another way I've shown you on a previous problem. And we have more space to do more examples. So let's do some. So number 3, we've got 2 to the 3rd times x to the negative 2nd, all raised to the negative 2nd. So we've got this one. And again, see if you can do it. So pause the video and see if you can do this one on your own. So when I'm going to be doing this one, I'm going to take 2 to the third, and I'm going to multiply 3 times -2, which is going to give me -6. Then I'm going to take -2 times the -2, which is going to give me a +4 in here. And then I need to go ahead and take 2 to the -6, or I can rewrite it as x to the 4th all over 2 to the 6th. And 2 to the 6th, what is that, 64? Okay, yes, 64. So we've got x to the 4th all over 64 for our final answer. And I just want to point out that another way that you could rewrite that answer, which would also be correct, which would be 1/64 times x to the 4th, kind of like that. What would be not okay, so I want to make sure you guys are hearing this, what would not be okay is for you to write that as a decimal. So don't put that in decimal form. I don't know if that decimal, I think it terminates, but I don't want you writing it as a decimal. I want you keeping it there as a fraction. All right, another example. This should be number 4. So number 4, we've got x to the 3rd times x to the -7th times y squared all over x times x to the 3rd times y to the -5th. Again, pause the video. See if you can get this one done on your own. And I'm going to work through this one, but I want you to pause it right now and then work through it and see how you do on this one. So for me, I'm going to go ahead and combine the x's up top, and I'm going to say x to the -4th because I'm adding these right here. And then I've got y squared, and in the denominator, I'm adding these right here. So I've got x to the 4th, and then y to the -5th. And at this point, I'm going to, if we want to follow what I did on one of the earlier problems, we can bring everything up. And so if I'm bringing everything up, then it's going to be x to the -4th minus 4. And then it's going to be y squared minus a -5. And then at this point, we've got x to the -8. And y, this ends up being a 2 plus a 5, because minus the negative is going to give us 7. And then you can say, okay, well, if I'm also supposed to express my answer with a positive exponent, the x is going to go back down to the denominator. So this could also be written as y to the 7th all over x. Did I write down the wrong problem? It should be x to the 8 here. Let me double check something, because I have a different answer. I'll pause you just for a second so you don't have to sit here staring at me. So pause for a moment. I'm going to just double check something here. Okay, we are good. What's written on the board is correct. There was a mistake in my answer key, but it is correct right here. So we're good. It's always a moment to celebrate. All right, so let's try another one. This is one of the harder problems. So we've got 2 different quantities. We're going to take 5z to the 3rd all over 2a squared. And then it's going to be raised to the -3. And then we've got another quantity of 8a to the -1 all over 15z to the -2. And then we're going to raise that entire quantity to the -3. So again, I would urge you just to kind of pause the video and see what you're going to get on this one. I would also give you a hint here that I would say you're going to need to be using, where is it? Especially these right here. You're going to be needing to use those rules when you get ready to do this one. So again, I would pause the video and just see what you get. So there's all kinds of things that you can do in order to solve this problem. I'm just going to show you one way, and you might have approached it differently, and that's okay. So I'm just going to take the -3 and I'm going to distribute it to every single term and see what happens. So we would have 5 to the -3. My z did not write in there. Z to the -9, 2 to the -3, and a to the -6. Then on the next one, I'm going to go ahead and just do the same thing. So I've got 8 to the -3, a to the +3, because negative times a negative is going to be positive. We're going to have 15 to the -3, and then z to the +6. So at this point, what I would do is take all the terms that have negative exponents, and we're going to flip them, whether they're in the denominator or the numerator, and flip them so that they have a positive exponent. So I just want to point out that on this one in particular, it probably would have been a good idea to just flip the numerator and denominator, which makes that a +3. That's another way you could have done it. And I'm hoping that some of you would have approached it that way to use one of your rules, but no need. We can do it this way too. All right, so what that means is that every term in this first fraction, every term in that first fraction is going to move to the numerator. The other two in the numerator are going to move to the denominator, and that's going to give them all positive exponents. So we're going to have 2 to the 3, a to the 6th, 5 to the 3rd, z to the 9th, and then on the right-hand side, the 15 is going to come to the numerator to make it a +3. A is going to stay right where it's at because it's already positive. And then we've got 8 to the 3rd, and then times z to the 6th is going to stay right where it's at. So then I would tell you to move the numbers to the left, move the variables to the right. You can also just kind of do that in your head, where you're taking 2 to the 3rd and then times 15 to the 3rd. So I don't know what 15 to the 3rd is, but 2 to the 3rd here is going to give you 8, and 8 times whatever 15 to the 3rd is. I would go ahead and multiply those things together. And then, so what we would be getting is 8 times 3,375 times a to the 6th times a to the 3rd. And then we're taking a 5 to the 3rd, which should give you 125 times 512, which is 8 to the 3rd, times z to the 9th times z to the 6th. And now we're ready to just combine our variables and multiply our numerator and denominator and then reduce at the end. So in our numerator, you should be getting 27,000 when you multiply that out. And then adding these, we now have a to the 9th. And then multiplying our 125 times 512, you should be getting 64,000. And then we're taking z and we're adding these, and that's going to give you 15. Z to the 15th. So then we need to reduce. We can totally take out something out of the 27,000 and 64,000. Like, let's do some dividing, or you could cross off some zeros, right? So every time we're dividing, crossing off zeros, we're dividing by 10. So let's divide by 1,000 on each of them. And then we're going to get 27 a to the 9th all over z to the 15th. I'm sorry, not just z. I should have a 64 down here. Just forgot to write it. So we should have 64 z to the 15th. And then I would check, is there anything that can go into 64 that also goes into 27? So just checking that, and you could check your divisibility rules for 3 and 9 if you wanted to for 27. And what you find out is that that's as far as it'll go, because it's reduced right there. One more I want you guys to try. And this one you're going to have kind of another challenge problem on this one. And so this one we have got -3 y to the 3rd x to the 3rd times -4 y to the 4th x squared times x squared, and we're raising it to the -4th power. And we are going to put that all over 18x to the third y squared times y to the third raised to the third times x to the third raised to the negative second. So once you, again, pause the video, try it out, see if you can get it, and then compare with my work here. So the first thing I'm going to take care of are these pieces right here. I would urge you to do that first. And so then I'm just going to rewrite this part, negative 3, y to the third, x to the third, negative 4, y to the fourth, x squared. Then I'm going to have x to the negative 8. In the denominator, I'm going to have 18x to the third y squared times y to the ninth times x to the negative 6. I don't know if you noticed, on the denominator I got rid of my parentheses. On the numerator I didn't. There's no rhyme or reason for that other than the numerator it started with parentheses, so I went ahead and just left them in. The parentheses and the numerator are no longer needed other than it helps us distinguish that this right here is a negative sign, not a subtraction sign. So just hoping that you recognize that every operation in between all three of these terms at the moment is multiplication. And so what I'm probably going to do, and again, you could approach this differently, I'm going to take care of all my numbers, then I'm going to do my x's, then I'm going to do my y's. And so I've got negative 3 times negative 4, which is going to give me a positive 12. Then I'm going to take care of my x's. So I've got x to the third. So I'm going to say 3 plus 2 minus 8. So that takes care of this one as well. And then I also have my y's in here. And so then I've got times y to the third, right? Times y to the fourth. In my denominator, I don't have any other numbers. I just have 18. And then I'm going to have x to the third minus 6. And then I've got y squared and then y to the ninth, which is going to look like that. And I don't mean multiplication, I mean addition right there. Okay, so we're ready to keep combining. And so here for our number, we're still going to have 12. We've got up here, we've got 5 minus 8, which is going to give us a negative 3. And then here for our y's, we've got 7. Then in our denominator, we've got 18x to the negative 3, y to the 11th. All right, so here at this moment, I'm hoping you see that the x's are actually just going to cancel out, right? Because you have x to the negative third over x to the negative third, which is the same exact number over the same exact number, which is going to reduce to 1. And so our x's are actually just going to completely cancel out. Some students of mine have not liked the negatives, and so they have gone the extra step of writing it like, you know, they flip it around and they write x to the third over x to the third, and then they cross it off. That's fine too. I'm just going to cross it off here. I have no idea why that's just erasing. But I'm going to come over here because that's being annoying, and we're going to have 12 y to the 7th now, and 18, we should have y to the 11th still left to deal with. So here, let's go ahead and reduce. We can take a 6 out, so that's going to be 2. That's going to be 3. We're going to subtract off 7 here. And so we are going to end up having y to the 4th in the denominator. So we have 2 over 3 y to the 4th. Or you could write it as 2/3 y to the negative 4th as well. So either of those answers would be correct. And again, if you have questions on that, just let me know because that's going to be the end of this lesson. Thanks, guys.